All right. So in this particular unit, we are going to discuss risk management, right? So this whole idea of risk management is linked to uh, uncertainties, right? And uncertainties are all over, right? Bad things happen in life. Incidentally, in our most recent live interaction, our Google Meet interaction, which we had, I think, on Thursday last week. I know some of you, if my memory serves me right, it was Chengo, I think, who was complaining that currently only two individuals that are a part of the project that they're working on are actually putting in the work into the project, right? Um, I think she mentioned something to the effect that some people are apparently located in parts of the country where they have intermittent internet connectivity or something to that effect, but that's besides the point. I'm glad that we've got into a stage where we are beginning to notice uncertainties associated with project management, right? By drawing comparisons from these small little projects that we're working on, right? So all of these things that you're pointing out, these are all tied to risk, right? So we want to figure out exactly how we plan for such uncertainties, how we go about mitigating or trying to really come up with workarounds on how to fix those issues or prevent those things from happening. All right, so risk management is essentially just concerned with identifying these uncertainties or problems, so-called risks, right? Drawing up plans on how to minimize those risks and the effects that they might have on the project. So fundamentally, that's what risk management is all about. So identification of risks and mitigation of risks. But of course, in between identification and mitigation, you have processes or procedures that are associated with monitoring the risks, right? Right. So, so software risk management is important because of the uncertainty associated with software, and some of these things we raised early on when we provided motivation for why project management is important. So things to do with the fact that unlike other engineering products, software is intangible, right? So there are inherent problems associated with software due to that particular attribute. But other than that, we have to remember and appreciate the fact that, especially early on during the project, the requirements that you tend to work with are generally loosely defined, right? The initial set of requirements that you'd work with as you are planning the project or as you're undertaking the project in the early phases or stages of the project would not be comprehensive enough. And in fact, in certain instances, they wouldn't even be correct, right? This is one of the reasons why you go through a thorough requirements engineering process or phase, which ultimately is meant to result into the production of a so-called requirement specification document, right? So the problem here is you want to manage the risk associated with software projects because usually the requirements that you work with are constantly changing or potentially constantly change, right? So as you're managing this risk, or rather risk management will involve that you anticipate the risks that will be associated with the project. So early on in the project, once you initiate the project, so you bid for a contract, you awarded the contract and you initiate the project, you want to anticipate what sort of risks would be associated with the project. Not only that, you want to be able to understand exactly what effect those risks would have on your project, right? The product that you're going to ultimately produce and the business within which that product is going to be is going to be used, right? And more importantly, you want to make sure that you mitigate those risks, right? So you undergo a series of steps where you avoid or you minimize those risks, right? So risk mitigation. So there's ideally there's two dimensions associated with risk classification or risk identification, if you will. So the first part would involve you identifying the type of risk, right? And then you then figure out exactly what is going to be affected by those particular risks, right? So the types of risks would be things like risk associated with the estimation of the cost, estimation of the project schedule, right? There would also be technical risks, organizational risks, right? So risks associated with the software development company itself that's developing the product, right? And tooling risks as well. But fundamentally, these project risks will tend to affect the schedule, the resources or costs, right? So two key things here. And to a certain extent, actually, here, I'm not sure why we forgot this, but the quality as well. So the risk is going to affect all those three things that we introduced as part of the triple effect, right? Quality, cost, schedule, right? All right. So business risks will tend to affect the organization that is developing the product or procuring the software itself if you're getting it from elsewhere. This is fairly common, by the way, in this part of the world, where most of the people that will bid for these projects, software projects that advertise in the papers, will not necessarily be software development firms. What they do is they will bid for a project. Once they are awarded the contract, they will then subcontract people to work on the project, right? If you happen to find yourself in a situation where perhaps you run your own software development firm, you probably realize, once you graduate, obviously, you come to the realization that it is sometimes cheaper to subcontract development work, right? So you have this firm, you probably be bidding for projects, but if the manpower that you have is not competent enough to develop that piece of software or some parts of the software, then what you do is you subcontract people from elsewhere, right? Incorporate them into the project. Very common practice, standard practice, really. All right. So in terms of risk classification here, just some examples here of types of risks and what they affect. Remember, I said there are two dimensions to risks: the type and what they affect. So some examples here: staff turnover, right? That would be a risk. This would definitely affect the overall project, right? An example would be, classic example would be somebody leaving the project midway through. So you start the project and you estimate that you need to work with 5 developers. You also estimate to say the project is going to, or the developers are going to take 3 months to develop the product. Towards the end of the first month, 2 developers decided to resign and leave, right? Just because they found a better opportunity elsewhere. That particular risk will definitely affect the schedule of the project, right? Because you need to rehire people, right? And rehiring of people obviously generally results in delays, right? This is a well-known fact. It's well documented. If you want to find out more about this, you probably want to read up complete graph, right? Yeah, complete graph, and you'll be able to get an appreciation of the effect that introduction of new stuff to a project might have on the overall schedule of the project. Right, so another example of the risk or type of risk is hardware unavailability, right? Again, this will affect the project. So an example would be essential hardware that you need to use as part of the project not being delivered on schedule or on time. These days, with the hype around so-called Internet of Things, there are specialized pieces of hardware that are being incorporated into projects. So if you're working on such a project and the hardware that you want to work with is not delivered on time, then obviously that's going to affect the overall project, right? In this case, it would be the overall project schedule. Yes. Another risk is requirements change, right? if the requirements change, then you know that the overall project is going to be affected. How? Well, so changing requirements would typically mean that the project schedule would be affected, right? But also changing requirements would affect product, because you know that the requirements are directly tied to what you're producing, which is the software. Yeah. So an example here is changes to the requirements are suggested by, let me just do this, I guess, are suggested by the, wow, apologize for that, I guess it's review, are suggested by the clients, right? All right, do that. All right. So specification delays, again, this would affect the, similar to requirements here, it will affect the product and the project, right? And then underestimation of the relative complexity associated with the project or the product that you're developing. This would definitely, if you underestimate the size, you are going to affect the overall project here. Why? Because the cost estimate is going to be wrong. Sorry about that. The cost estimate is going to be wrong, right? And because the cost estimate is wrong, the project is going to be affected, right? This is also going to affect the product itself, right? And then there are also risks associated with computer-aided software engineering tools that you end up using, right? This will generally affect the product here. So an example would be the adopted case tools not being able to perform the expected task, right? If this happens, then what you'd have to do is you'd probably have to adopt a separate tool, if you will, and so this ultimately affect the product itself. Technological changes, right? We introduced this. We've introduced this in the past. I think in lecture series number 2 during our discussion of coping with change. We also mentioned it when we discussed estimation techniques, right? We keep mentioning the fact that when it comes to development of software, we need to be aware of the fact that technology changes at a relatively fast pace, right? So the tools that we are using right now are not going to be the tools that people are going to be using or that you end up using 2 or 3 years from now, right? So this would affect the business, obviously. And then product completion obviously also affects the business, right? So examples would be the product is marketed way before the system is completed, right? A point to note here, the reason I'm walking us through this risk classification is that some of these risk types will typically manifest themselves in more or less all software projects that you end up working on, but some of them are specific to a particular domain that you might be working on, right? So things like hardware, for instance, might not necessarily affect the projects that we're working on. But also, a point to note here as you're going through these notes is to think about the risks associated with the respective projects that you're working on, right? And what you soon realize is that the risks that you identify are going to be different because you're working on different types of projects. All right, so hopefully this example is, I guess, this example is going to be helpful in helping you identify the risks, because as it turns out, if you revisit the project specification document, what you realize is that the proposal document is supposed to incorporate some aspect of risk management, right? And so what you'll be expected to do is to draw up a comprehensive list of all risks associated with the projects that you're working on, what those risks are associated with, so what exactly do they affect, and then you also be expected to draw up a priority list of the risks, right? So you come up with priority tags associated with the risks, the severity of the risks, and more importantly, mitigation measures associated with the identified risks. All right, so the risk management process essentially involves 4 key components. So you have risk identification, risk analysis, risk planning, and planning is back, and then risk monitoring, right? So the first starting point is you want to be able to identify the comprehensive set of all risks associated with the project you're working on. Once you do that, as you're executing the project, you want to do some sort of risk assessment, right? So you assess the likelihood of the risks happening, right? In certain instances, there are certain risks that you identify that are more likely to happen. Like for instance, if you're working on a project, a multi-year project, for instance, it's likely that you experience staff turnover, right? People die, people move on in life, right? So-called green pass or something. People gravitate more towards things that make them more happy and things that will give them or result in them making more money. So staff turnover will likely happen, right? So these are things to think about. So you do a risk assessment, right? Where you figure out the consequences of those different risks. You prioritize the risks, right? So you typically come up with a priority list that will indicate whether this is a high priority risk, whether this is a high priority risk, whether it's more likely to happen or less likely to happen. And then you go through a planning process where you draw up plans on how you're going to mitigate the risks, right? So how do you avoid those risks that you've identified? And then finally, as you are executing the project, you constantly monitor the risk, right? Now, because there's an aspect of monitoring the risk, you realize that this is a continuous process. Key point here is that it's not enough to just identify the risk and then you analyze them and then you draw up plans for how you're going to mitigate the risk. You have to constantly monitor, right? And so this block diagram here best summarizes the things that we just spoke about now. We were saying the first thing you have to do is you identify all the risks associated with the project, right? The output here is a comprehensive list of all potential risks, everything that you think can potentially affect the relative success of the project. Staff turnover, requirements change, everything needs to be identified. So you enumerate these things and then you undergo a risk analysis process where you prioritize the risks, right? So identify whether each of these listed risks is a high priority risk or a low priority risk or medium priority risk or some such notation. And then you do risk planning, right? Essentially trying to come up with ways in which you're going to mitigate the risks. How are you going to avoid or minimize the risks from happening? And then you constantly monitor, right? So the output here would be some risk assessment report. All right. So this is usually, so the process of risk identification is usually a team effort, right? Even more so in your case where you're working in these group-based projects, right? So all 5 of you or all 4 of you would have to sit down and come up with all potential risks associated with your respective projects. And like I mentioned, there are certain risks that would be specific to the domain for which you're developing that piece of software, but then there's some risks that are generic in nature, right? So for instance, the risks that would be associated with a piece of software that is going to be used in the aerospace industry is going to be completely different from some risks associated with the financial sector, right? But in all those different instances, there are generic risks that are aligned or associated with technology, organization, people, right? And people are always a problem. People always leave and resign. People will be lazy, right? It's a risk. Potential risk for a project is people not putting in the work, right? So you have to think about how you're going to mitigate that. Risks associated with the requirements, right? Changing requirements, estimation risks, right? There's a high risk that you end up, you underestimate how long the project will take. So what do you need to do if that is going to be the case, right? There's a risk that you will underestimate how much the project will cost. What do you do to mitigate that risk, right? who knows, maybe you overestimate or something, right? All right. So examples of these risks, right? Again, in terms of estimation here, it will be things like underestimating the time that would be required to develop the piece of software. Right? You sit there, you go through the initial requirements coming through the customer, and you think you can develop this piece of software in 3 months, right? There's a risk that in actual fact that piece of software will take maybe 6-7 months or even a year to develop, right? So there's a risk that you might underestimate the relative size of the software, right? These are other examples associated with organizational risks. So things like the structure of the organization, budget associated with organization. People risks include things like it not being possible for you to recruit people with the required skill, right? So here's the thing: if you bid for a project that requires that you develop some piece of software for, I'm trying to think of a wild example here. Okay, let's say you bid for a project for some private hospital, and they tell you to say they want some application that is going to incorporate aspects of machine learning or artificial intelligence, right? And you discover, artificial intelligence, a risk could be that you'd be unable to find individuals in Zambia that have the experience associated with that particular requirement. So that's a risk, right? Another risk associated with people here is some members of staff, important members of staff, not being available at critical times of the project. Another example of a risk associated with people is maybe you discover that developers need to undergo training for them to be able to do a particular task associated with the project, right? So, so these are all, again, these things we are working through here, some generic risks, right, that may not be, so these are generic risks that are associated with software projects irrespective of the type of domain for which that piece of software is being developed for. All right, and then in terms of risk, risk identification, risk analysis here, what you're doing is you're just assessing the likelihood of the risk happening, right? And the way you do this is you typically, it's common to use the Likert scale type rating, where you typically come up with these ordinal values that will represent the likelihood of a risk happening, right? So is the severity of the risk very low? Is it low? Is it moderate? Is it high? Or is it very high, right? Is it a low priority risk, high priority risk, or very high, for instance? Right, and some consequences associated with the risk could or might as well have to be identified. So you come up with, again, scales like catastrophic, serious, or tolerable, or insignificant. Excuse me. All right, so an example of output, I guess, of the risk analysis process. Remember, we mentioned that the output here would be, for risk analysis, would be a priority list of the identified risks, right? So risk identification results in the list of all potential risks associated with the project. Risk analysis will result in the priority list of all the identified risks, right? So it will be something similar to this. So for each of the identified risks, hopefully each of the identified risks would be tagged by what they are affecting, right? So the type of risk, is it affecting estimation, organization, people, requirements, technology, tools, or whatever else associated with the risk. And then, more importantly, you indicate the likelihood or the probability of that risk happening, right? So is this a moderate risk? Is it a low risk, right? And then you also come up with a metric to identify the effect associated with that risk. Is it a catastrophic risk, right? Is it something that will result in really project failure? Is it serious? Is it insignificant, right? Again, these are things that will be expected in the project proposal, so you want to make sure that you understand how to come up with this priority risk and identify the effects that a particular risk might have, the overall success of the project. So for the projects that we're working towards, we can just work with these ratings. It should be fine. So we'll use this like a scale to provide priority rating associated with each of the risks that will be identified, and then we'll also use this particular rating to signal the consequences associated with the risk, the type of effect it would have on the project. Is it catastrophic, serious, tolerable, or insignificant? Again, you realize that this risk analysis process is a team effort. It's best done as a team, not as an individual, right? You need an extra pair of eyes to be able to ensure that you're doing the right thing. All right, so in terms of the planning process here, what you're doing is just for each identified risk, you come up with a strategy on how you're going to minimize that risk or manage the risk, right? And essentially the type of strategies that you come up with are things like how can you avoid the risk? How do you avoid people from being unavailable at critical times? Now, there are certain things that you have no control over. Like, and I'm sorry to use this example, but Ms. Luswaniso mentioned that Peter was sick. Peter was supposed to work on some aspect of their project, and he was sick, and they were actually glad that the current deadline was extended to Friday, because that would give them time to work on this, right? So I guess what I'm trying to say is for each of these risks, so you identify something like this, somebody not being available at critical times, you have to think of how you're going to avoid something like that, right? So what sort of strategy do you come up with to avoid that from happening? Well, you can't avoid someone not being available, especially if they're sick, right? So I don't know if you can avoid that, but you can certainly minimize. You can minimize that risk. How do you minimize it? If you're a group of 4 or 5 people, I mentioned during the live Q&A session that what you could do as a group is decide to say, if you are splitting up roles or tasks, make sure that each task is being worked on by at least 2 people. In an ideal case, what I would do if I were you is I would ensure that each task is being worked on by all group members, so that in the event that some people are not available, then the other members of the group will be able to carry on with that particular task, right? So you notice that what I'm describing here is what you'd classify as a contingency plan, right? So you need to come up with a contingency plan, a workaround, if the risk arises. All right. But a common approach to risk planning really is to ask what they call what if questions, right? So as you are coming up with these contingency plans, a nice way of planning for risks is to ask what if questions. What if Peter is sick and is unable to do the work? What if some group members are too lazy to do the work? What are we going to do? Right? These are all approaches, a nice approach to use, especially if, as you're doing this for the first time, because you have little experience planning for risks, right? So you want to ask as many what if questions as possible. What if, right? What if the reusable component is not the best fit for the project? What if the reusable component that we're thinking of using requires that we pay money, right? It's a risk. And this came up, I can't remember where this was coming from, but I remember it must have been Clement, not Clement from the union, but the other Clement, who raised the issue that they had found a reusable component that they were thinking of integrating into their project. But alas, it's a component that requires that you pay for a subscription or something. You pay for a license or something like that. If you think that's a risk, then you need to find a workaround, right? So what if some project team members are unavailable, right? What if the client is unable to provide a comprehensive set of requirements? This is a very common thing. a client may not know exactly what they want, so you have to help them figure out what they want. All right, so some examples here. I won't really walk through all of them here, but just to mention that for risks associated with staff illness, for instance, you reorganize the team so that there's more overlap of work, right? So what you have to do is make sure that you understand what everybody else is doing. Now, you see, when we asked that you come up with a risk matrix for all the different tasks associated with the project, we anticipated that this would happen, right? So this is 158. If I scroll down, if I scroll up to the risk matrix, if you come up with an appropriate thing like this, what you soon realize is even though you have a designated team member who will be responsible for that particular task, but if a good fallback plan will ensure that another key person is accountable, right? So the person will be following up to ensure that this person is actually doing the work, right? It's a nice way of trying to plan for risks, by the way. So you reorganize the team. The work around here, the plan would be to reorganize the team so that there's more overlapping work. And a nice way of reorganizing the team is that's what I showed you here. You implement that risk matrix, right? So we're not coming up with the risk matrix just for sure. There's a reason why we're doing that. All right. Some other examples here is, I guess a common one is requirements change. So how do you plan for this? Derive traceable information to assess requirements change impact, right? Maximize information hiding in the design. All right, so in terms of the risk monitoring process, which is the last phase, remember I said risk identification. You prioritize the risks, right? Risk analysis, risk planning, and then risk monitoring. So identify the list of potential risks, prioritize them, come up with a contingency plan, and then you constantly monitor or you assess. So the monitoring process is pretty trivial, really. For each risk, you want to regularly you decide whether or not it's becoming less or more probable, right? So as you're monitoring, you want to constantly assess whether or not the risk is going to fall under very low priority or very high priority. You also assess the effects of those risks, right, to see if they're changing. Because it turns out that for certain risks, the effect is going to change. So for things to do with the requirements, if you remember, we said that early on in the project, and I'm sorry to take you back, but we mentioned that early on in the project, there are going to be a number of uncertainties, right? But as you progress, as you work through the project, you notice that you become more certain at what you're doing. This applies to the requirements as well. Early on in the process, you are uncertain as to what exactly you're working towards. I have a sneaking suspicion some of you don't still know what exactly you're working towards. But once we go through the requirements engineering process, you realize that to gain an in-depth understanding of what it is we're working towards, right? So what we're saying is that as you progress through the project, the risk associated with requirements, the effects that it will have will become less, right? If I can find it. So I guess it would move from serious to insignificant or something. All right, and then each risk should be discussed at management progress meetings, right? In our case, this is tied to these weekly face-to-face meetings that you'd have. So as part of these weekly meetings, the expectation is going forward that at some stage anyway, is once you draw up the comprehensive list of risks associated with the project, what you must do is as part of your project meetings, you discuss the risks, right? And assess whether the effects that they have on the relative project is changing. Assess whether the probability or the likelihood of them happening is changing, right? That's all part of risk monitoring. All right, so some indicators of the type of risks here: risks associated with estimation, year failure to meet agreed schedule, failure to clear reported defects, for instance. These would be the indicators that you're using to monitor the risks associated with estimation. And the common one here that's probably going to manifest itself in these group-based projects that you're working on, I don't know about poor staff morale here. Maybe I would like to think that the morale is going to be high, seeing the marks associated with the projects you're working on. But perhaps something to do with the poor relationships amongst the team members, right? You'd have to figure out exactly how to fix it. So an indicator, so risk associated with people, key indicators would be morale, high staff turnover, and I guess you could add to this mix here, if we could relate it to the projects we're working on here, is more and more group members not showing up for meetings or something. That would be an indicator, right, of the risk associated with people. But the key thing here is that for you to monitor risks, right, what this table is saying is for you to be able to monitor these risks, you need to identify metrics that you're going to use to monitor the risk. You see, when you're monitoring something, when you're monitoring something, effectively what you're doing is you're measuring, right? For you to measure something, you need a metric to measure that thing, right? So what we're saying is for you to be able to monitor the risks that you'd have identified, you need to identify exactly how you're going to measure those risks, right? So you need to identify metrics. Metrics or indicators. So these are examples of indicators that you would use here. All right, so to recap here, in terms of risk management, we just went through the process that you go through to undertake this whole risk management activity. You identify all the potential risks associated with the project. You analyze the risks. You plan for the risks, and then you monitor the risks, right? So this is what we did. All right, so in the next unit, we briefly look at people management, right? So I'll see you in the next unit.